Good morning, my dear students of Standard 9. Welcome back to the chemistry class. Dear students, we are talking about Chapter 5, Chemical Bond. Already we had completed ionic bond and covalent bond. And we know the compounds having ionic bond are called ionic compound and the compounds having covalent bond are called covalent compound. Today, in this class, we will learn about some characteristics of ionic and covalent compounds. There are some general properties of these compounds. Not only this, by these properties, the compounds can be differentiated from one to another. So, today we will learn properties of ionic and covalent compounds. Some of these properties are melting point and boiling point, solubility, and electrical conductivity. These properties can make sure that the compound is ionic or covalent. Ionic compounds have some properties and covalent compounds have also. For example, melting point and boiling point. Melting point and boiling point of ionic compound is very high. Most of the ionic compounds have high melting point and boiling point, whereas covalent compounds have low melting point and boiling point. So by seeing this melting point and boiling point, we can tell the compound is ionic or covalent. Look here. These are the properties of ionic compound and covalent compound. At first, state at room temperature. Ionic compounds are crystalline solid. Most of the ionic compounds are crystalline solid. And covalent compounds, they can be liquid, gas, and also they can be solid. Melting point of ionic compound is very high, whereas covalent compounds have low melting point. Electrical conductivity. Ionic compounds are electrical conductor as a liquid. That means when you will melt the ionic compounds or when you will make the solution of ionic compound, then ionic compounds can conduct electricity. But covalent compounds, they cannot conduct electricity. Solubility in water. Most of the ionic compounds are highly soluble into water. That means ionic compounds have high solubility into water and covalent compounds have low solubility. Most of the covalent compounds are insoluble into water, or we can tell they have low solubility into water. Conducts electricity when dissolved in water. I told it that ionic compounds can conduct electricity in molten state or in solution. But covalent compounds, they cannot conduct electricity in their solution also. So, in this class, we will learn about melting point, boiling point and solubility into water. At first, melting point and boiling point. I told ionic compounds have high melting point and boiling point, whereas covalent compounds have low melting point and boiling point. Now, why ionic compounds have high melting and boiling point? Ionic compounds contain positive and negative charges which remain tightly connected with one another. You know this. It would take a lot of energy to overcome the strong electrostatic forces that hold the ions of an ionic compound together. That means when you want to melt the ionic compounds, you have to break the ionic bond, which is held in between a cation and an anion. As a result, the melting point and boiling point of ionic compound is very high. Whereas molecules in covalent compounds are held together by weak intermolecular forces. Look, ionic compounds, there the positive ion and negative ions are attached with one another and they form a giant molecule. But covalent compound, here each molecules are attached with one another by weak intermolecular force, that is called van der Waals force. And this van der Waals force, this is very weak, so at very low temperature the van der Waals force is broken and the covalent molecules become liquid or become gaseous. So the melting point and boiling point of covalent compound is comparatively low. Thus, less heat energy is required to overcome these weak forces. As a result, the melting point and boiling point of covalent compounds is very low. So, dear students, here look one thing. When you will melt ionic compound, then you have to break the bond. When the bond is broken, then ionic compounds become liquid. That means in liquid state there is no ionic bond, just the ions are freely move in the solution. But covalent compound, when you will melt a covalent compound, the covalent bond is not broken. Rather, the molecules are separated from one another. That means the van der Waals force is broken, but the covalent bond, this is not broken. So, ionic bond is strong as well as covalent bond is also strong. But to melt a covalent compound, you have no need to break this covalent bond. Look, this is ionic compound. When heat is given in this ionic compound, then this ionic bond is broken and the ions, they are freely move in the melted condition of ionic compound. When ionic substance melts, the giant ionic lattice is broken. It is molten state. The ions are free to move around. Here no ionic bond is there. Here the positive ions and negative ions are separated from one another. To free the ions during melting, the ionic bonds must be broken. I told it that to melt an ionic compound, ionic bond is broken. The ionic bonds are strong, so lots of energy is needed to break them. This means ionic compounds have high melting point and boiling point. Now look, this is the melted state of covalent compound, where here the molecules, they just stay side by side for the weak intermolecular force. But when it is melted, then they are separated and the molecules are separated from one another. The intermolecular force, van der Waals force, is absent in this liquid state of covalent compound. Covalent discrete molecular substances have high or low melting points. Most of the time, the melting point is very low here. This is because they are made up of discrete molecules held together only by weak forces. These separated molecules, discrete molecules, they are bonded by weak van der Waals force. The molecules are separated using high or low energy. Most of the time, at very low energy, the molecules are separated from one another. But again, you have to remember one thing, that to melt a covalent compound, you have no need to break the covalent bond. Only the van der Waals force is broken here. But to melt ionic compound, you have to break this ionic bond. Look here, this is sodium chloride ionic compound. When it is melted, the ions, sodium ions and chloride ions, they are separated from one another, and now there is no ionic bond. But water, this is covalent compound. In water molecule, there are weak van der Waals force between them. So this is in liquid state, but when the force is totally broken, then it will become gaseous. So at very low temperature, the force can be broken, but to break this ionic bond remain between sodium ion and chloride ion, high temperature or very high amount energy is needed. There are some compounds, these are ionic and covalent both. The melting point and boiling point chart is given here. Look, ethanol, by seeing this melting point and boiling point, you can understand the compounds are ionic or covalent. The compounds that have high melting point and boiling point, they will be ionic compound, and the compounds having low melting point and boiling point will be covalent compound. Here look, ethanol, melting point minus 114 degree and boiling point 78.3 degree. So it is covalent compound. Ammonia minus 77.7 and boiling point minus 33.3. So obviously it is covalent compound. But cesium bromide, its melting point is 636 and boiling point 1300. High melting point and boiling point. So this is ionic compound. In this way, look here, magnesium oxide, it has high melting point and boiling point. So it is also ionic compound. Sodium chloride, its melting point 801 and boiling point 1465. So it is also ionic compound. But other compounds, their melting point and boiling point is very low. Even look, their melting point and boiling point are minus value. That means at room temperature, at normal temperature, they are gaseous. So these all are covalent compounds. Now our second property, solubility, that we already knew here that ionic compounds are soluble into water and covalent compounds are insoluble into water. To understand this, at first we have to know about water. We know that water is a universal solvent. That means water can dissolve almost all the compounds. But here covalent compounds are not soluble into water and ionic compounds are soluble into water. Most of the ionic compounds are highly soluble into water. Why? Because water has a special characteristics. That is, water is a polar solvent. Water is a polar solvent. What is polar solvent? Dear student, now at first we will know about polar compound. All ionic compounds are polar compound because polar compound means the compounds that have two opposite poles, positive and negative pole. Ionic compounds, they have positive and negative poles on their both side. So ionic compound is polar compound. But water is a covalent compound. But water is also a polar compound. Now polarity, a compound will be polar or non-polar. It depends on the electronegativity difference of the atoms that are present in a molecule. So, at first we will know about electronegativity. Dear student, you learned in your previous chapter, chapter 4, a periodic property electronegativity. Look, polar molecules only dissolve into polar liquids. That means I told ionic compounds are polar compound. So they are polar molecules. They are dissolved into polar liquids. That means water. Water is also a polar liquid. For example, salt dissolves into water. Salt, sodium chloride, is ionic and water is a polar molecule. That means it has polarity. So, look, this is the electronegativity chart that you had learned in your previous chapter, periodic properties, where the electronegativity of some elements, of all the elements are given here. You have no need to memorize the electronegativity of all elements. Just very limited element, some common elements electronegativity you have to know. And the difference of electronegativity will measure that a compound will be polar or non-polar, or a compound will be ionic, polar covalent or pure covalent. Look, this is the electronegativity chart, where the highest electronegativity, that is fluorine has the highest electronegativity 4, and the metals, they have low electronegativity. Now this is the chart, the difference of electronegativity. If the difference of electronegativity of two bonded atom is 0, then the compound will be pure covalent. And if the difference of electronegativity is medium, then the compound will be polar covalent. And if the difference of electronegativity is high, then the compound will be ionic compound. Look, pure covalent compound, they have the difference of electronegativity 0 to 0.4. If the difference of electronegativity of two bonded atoms is 0 to 0.4, then the compound will be pure covalent compound. For example, chlorine molecule, where two chlorine atoms are bonded and both their electronegativity is 3. So the difference of electronegativity is 0 here. So chlorine is a pure covalent compound. Methane, the electronegativity of carbon is 2.5 and the electronegativity of hydrogen is 2.1. So the difference of electronegativity is 0.4. So methane is also a pure covalent compound. If the difference of electronegativity is between more than 0.4 to 1.8, then the compound will be polar covalent compound. Now look, water. The electronegativity of hydrogen is 2.1 and the electronegativity of oxygen is 5. So the difference of electronegativity is 1.4. It lies between this range. So water is a polar covalent compound. And if the difference of electronegativity is more than 1.8, then the compound will become ionic. Nonpolar or pure covalent compound has the difference of electronegativity less than 0.5. Polar compound has the difference 0.5 to 1.7 or 1.8. And ionic compound has the difference more than 1.7 or more than 1.8. Just this range you have to remember. Then by seeing the compound and by calculating the difference of electronegativity, you can determine a compound is ionic, polar covalent or pure covalent. Now, why water is polar covalent compound? Already I have discussed it. Water is a covalent compound where two hydrogen atoms are connected with one oxygen atom by electron sharing. That means it is a covalent molecule. But the electronegativity difference of oxygen and hydrogen is 1.4. It lies between 0.5 to 1.8. So water is a polar covalent compound. When a compound is polar covalent compound, then this shared pair of electron, it is attracted by oxygen more. Here the shared pair of the electronegativity of oxygen is more than hydrogen, so the shared pair of electron is attracted by oxygen more. So oxygen becomes partially negatively charged and hydrogen becomes partially positively charged. That means here two opposite charges arise on both pole of water molecule. So water is a polar covalent compound. Dear students, I am telling again, here the electronegativity of oxygen is more than hydrogen. So this electron pair that are shared by oxygen and hydrogen, this electron pair, this is attracted by oxygen more. So it will go a slight to oxygen. So oxygen becomes partially negative charge and hydrogen becomes partially positive charge. So two opposite charges arise on both sides of water and water become polar. So water is a polar covalent compound. Look, here since the electronegativity of oxygen is more than hydrogen, the two shared pair electrons of water molecule move towards oxygen a bit. As a result, oxygen atom becomes a partially negative charge and hydrogen atom becomes partially positive charge. So in water molecule, partially positive and partially negative charge is created in both pole, and this type of charged polar compound is called polar covalent compound. Dear students, in ionic compound there are positive and negative charges present on the both side. So ionic compounds are polar, but some covalent compounds where the electronegativity difference of bonded atoms is more, for them partially positive charge and partially negative charge arise on both sides of these compounds. So these compounds are called polar covalent compound. Now, why ionic compounds are dissolved into polar covalent compounds, or we can tell why polar compounds are dissolved into polar solvent. Now look, ionic compounds, for example sodium chloride. When sodium chloride is given into water, the partially positive end of water, that means hydrogen ion, attracts the negative charge. For example, sodium chloride, if it is sodium chloride, then chloride ion of ionic compound, and the partially negative end of water, that means oxygen ion, attracts the positive end of sodium chloride, that means sodium ion. Look like this. When sodium chloride is given into water, this chloride is attracted by the partially positive charge of water, that means hydrogen ion, and this sodium ion is attracted by the partially negative charge of water, that means oxygen ion. Now, when this attraction becomes greater than the attraction that exists between the anion and cation of ionic compound, then they become separated from one another and become surrounded by water molecule. Thus, ionic compounds are dissolved into water. Now, when this attraction becomes more than the attraction of ionic compound, then the ionic compound is surrounded by water and the ionic bond is broken and the compound is dissolved into water. No. When ionic compound is given into water, then the ions, for example, this is sodium chloride. So now the sodium ions and chloride ions, they are totally separated from one another and the ions can freely move into water. This is the solution of ionic compound into water. Now, covalent compounds, they are insoluble into water. Most of the covalent compounds are not dissolved into water because covalent compounds are not polar compounds. Covalent compounds have not positive or negative end on both sides, but some covalent compounds are soluble into water. Which covalent compounds are soluble into water? The covalent compounds that are polar. That means the covalent compounds that have partially positive and partially negative end on both sides. They are soluble into water. For example, HCl, HF, methanol, they are polar covalent compounds. They have partially positive and partially negative end. So these polar covalent compounds are soluble into water. Why? Because they have also partially positive and partially negative end. So when they are given into water, then the partially positive end of these polar covalent compounds are attracted by partially negative end of water, and the partially negative end of these polar compounds are attracted by partially positive end of water, and these compounds are dissolved into water. Look, these are polar compounds. So when they are given into water, then their negative end is attracted by the partially positive end of water, hydrogen ion, and their positive end, these are attracted by the partially negative end, that means oxygen ion of water. So dear students, we can tell ionic compounds are polar, so ionic compounds are soluble into water, but covalent compounds, they are not polar, so they are insoluble into water. But some covalent compounds like methanol, hydrochloric acid, hydrofluoric acid, they are polar covalent compound, so they are dissolved into polar solvent water. Look, when polar covalent compounds are given into water, then they are dissolved into water. But interesting thing is here that when ionic compounds are given into water, then the ionic bond is broken and the ions are separated from one another. In solution of ionic compound, there is no ionic bond. The ions are separated from one another. But when covalent compounds are given into water, then covalent bond is not broken. Just these discrete molecules are separated from one another, but the covalent bond is not broken in the solution of covalent compound. Now, notice how the polar covalent molecules themselves do not split into charged ions. The solute molecules stays together and just separates from other solute molecules. Here they are not broken, so the charged ions are not separated from one another. This is ionic compound salt, sodium chloride. Sodium chloride, when it is dissolved into water, then the ions are dissociated and they dissolve. But when covalent compounds like sugar, when sugar is given into water, then the ions are not separated. The covalent bond is not broken. Just the molecules are separated from one another and they are dissolved into water. So dear students, today we have read two properties, melting point and boiling point and solubility. Next class we will read another property and also metallic bond. So thank you everyone. Goodbye to